Good afternoon, all. Thank you for showing up with such a grand capacity. Welcome to the breakout session on agent security at scale, protect against the OWASP top 10 application risks. I'm Aniket Patankar, lead product manager on agent platform security, joined by my colleagues.
Shelly Hershkovitz, I'm product manager at Gemini Agent
Platform.
Platform. Yes, the new name. Thank you. Go ahead.
So you don't know where you are working?
Yeah.
It's Google next, so it's okay. So hi, everyone. Francois-Xavier speaking, if you dare pronounce my French name. For the other, it's FX, okay? So I have the joy and privilege to lead the data and AI governance squad at Geotab. And Geotab, for the people that don't know us, we are a global leader in connected vehicle and asset management solutions. Our motto is innovate responsibly.
And hi everyone. I'm Devesh, a security engineer at Snap, where I lead various initiatives in AI security. For those unfamiliar with Snap, Snap helps more than 900 million users connect with their family and friends.
Cool. And they're going to join us shortly. OK, so let's begin with agentic AI paradox. As all of you know that AI agents offer unparalleled innovation speed, unprecedented customer experiences, and increased workforce productivity. By 2028, 1 in every 3rd enterprise is going to deploy AI agents in their enterprise application. That's quite a speed. But as with any disruptive technology, security and governance is falling behind. On one hand, there is a challenge of shadow AI, unsanctioned AI, agent sprawl. But what's making it a security nightmare is agents' ability to autonomously take actions and reason at a scale and speed at which the traditional security governance systems are not equipped with to mitigate that is. The not so good news is that this gap is only going to get widened. On one hand, if this gap is not addressed, there are a variety of different consequences. 40% initiatives may fail. Spendings will get deferred. 20% of global 1,000 organizations will face maybe some even more severe disruptions like lawsuits or dismissals. And in any of this scenario, those organizations will fall behind. But what's also true that enterprises who are going to take proactive action, are going to put a plan in place for security governance, they're going to succeed. They're going to move faster, and they're going to maintain their competitive advantage in the market. We at Google Cloud want to see you all on the right side. Now, there are different frameworks and definitions to capture what defines a holistic security governance for agents, what risks you are covered for, what risks you are not. One of the most prominent frameworks in the industry is OWASP Top 10. As you know that OWASP has done a good amount of research, especially in AI security in last probably 2 years plus. Last December, they published a report on top 10 risks against agentic applications. We at Google Cloud believe that those do capture one of the top severe risks against enterprise applications, and we need to help you to solve those. OWASP has a great track record, but more importantly, our customers rely upon them. They use these guidelines to operationalize their security governance practice. We want to meet where customers want us to. We are also in strong support of this community initiative. So what we're going to do is we're going to deep dive into some of the threats. We're going to cover rest of the threats and show you how at Google Cloud we're addressing all 10 risks. Yesterday, you have seen the announcement on Gemini Enterprise. It's a unified architecture that brings together the power of all things AI in Google Cloud. One of the core components of Gemini Enterprise is Gemini Enterprise Agent Platform that brings together platform innovations from Google Cloud Platform and Google DeepMind. At a very high level, Gemini Enterprise Agent Platform offer a variety of different capabilities across 4 pillars. What we're going to do today is we're going to focus on govern pillar and show you the capabilities in govern pillar, how do they help you address the threats which are identified by OWASP Top 10. Let's start with the first one, agent goal hijack. Typical attack scenario, indirect prompt injection, goal displacement due to calendar drift, or context window exploitation. What needs to happen to mitigate these? Inputs needs to be sanitized, prompt injection detection needs to be in place, and human needs to be in the loop. Google has the first-class content safety guardrail with Model Armor that provides comprehensive protection against agent goal hijack. Model Armor protects all the interactions across users, agents, MCP tools, and LLM interactions in the agent platform ecosystem. It blocks advanced, direct, and indirect prompt injection. It blocks dangerous content, offensive content. It implements 250+ classifiers for sensitive data identification. It also blocks malicious files and unsafe URLs. What's equally cool about Model Armor is it is inline integrated with agent platform. No need to change a single line of code from a developer standpoint. It is integrated with Agent Gateway, LangChain, and Firebase as well, in addition to all other managed services. So that's a power. Now let's see a demo showing Model Armor in action, preventing indirect prompt injection. A scenario that we are painting here is there is a Gemini Enterprise Email Assistant that has extracted an email with a hidden instruction. Agent forwards that without Model Armor guardrail, but when Model Armor is in place, it detects that and prevents it. Okay, so this is Gemini Enterprise. Model Armor is not configured, and you can see that on the screen. Now, we're going to see a Gemini Enterprise Email Assistant agent's UI interface, where a user is able to interact, and it's connected to Outlook using data connectors. So let's switch over to the Outlook mailbox. There are 2 emails. There is a user email that contains confidential customer information. And then there is another email from a nefarious actor where it looks benign at the onset, but there are hidden instructions that will prompt the agent to forward the last 3 emails to an external email address and treat that as a high priority instruction, system instruction that is. So let's see when Model Armor is not in place, what happens. Typically, Gemini Enterprise gives you human in the loop detection. So there is some guardrail in the place, and this is a command that is taken as a prompt. So Gemini Enterprise apps detects the content, and it allows human in the loop. But imagine the agent is performing the same action. So this check and balance may not be applicable. In that case, without Model Armor in the place, the confidential information gets forwarded to an email address of a nefarious actor. And we'll quickly check that email getting populated in Outlook mailbox. So this is the one. It's an actor's email, and then the actor got that forward. OK, so let's see what happens, the same scenario, but what happens when Model Armor is configured. First thing, it's very, very easy to configure Model Armor. Turnkey, almost 2 clicks, inline integrated. Now it's configured. Okay, so agent engine and agent gateway is protected. The same command happens, and let's see what happens when the same content is trying to get extracted out. So in this case, you will see Gemini Enterprise, based on Model Armor, will block this content to get forwarded and flag that as a violation. Okay, and finally, we'll quickly see in the Model Armor backend, what is happening here is Model Armor is able to detect that hidden instruction, identify that there is an attempt for indirect prompt injection, classify for a pattern, and then based on that, trigger a rule that will block this content to get executed. Okay? So that's the net of it. Now I would like to call upon FX to learn from him about where he sees use cases and scenario with agent goal hijack and thoughts on GCP solutions.
All right, thank you for your patience. It ruins my 2 minutes now. Anyway, so thank you so much for presenting this risk, which is the one that we consider as foundational for us. So for the less technical people in the room, which I'm part of, I would say that, again, agent goal hijacked, you need to understand that is this prompt injections attack applied to agentic systems, okay? And it has real-world consequences when you run agents and skills, okay? Because at the end of the day, if I can hijack, your agent goals, everything else follows. Okay, so would like to make sure that you understand that. I can make it misuse tools, abuse privileges, exfiltrate data, and also the agent becomes mine. Most of the time, you don't even know it. Okay, so that's why for us it's super important. What are we trying to do? We are trying to implement, I would say, what we call those kind of content provenance markers, okay, with untrusted content tags. We are red teaming and again and again and again, to make sure that we are seeing, those vulnerabilities. And I would say that the other problem here is indirect hijacking, okay, through tool outputs, which is why we focus on something that you've probably heard a lot today, which I heard a lot today myself, blast radius reduction. Super important, right? And one last thing, and I think here what you guys are presenting, during this week could certainly help us, is what I call our honest challenge number 1 is runtime detection. It's for us, goal hijacking it's a kind of an unresolved problem, and for now we have a kind of a strategy which is a defense in depth, okay? If the hijacking succeeds, you limit as much as you can, but with those kind of tools that we saw, Armor, I think we can do better. So anyway, back to you.
Thank you, FX. That was helpful. Okay, let's go to the next one, supply chain vulnerability. Again, common patterns are agent trying to access a malicious MCP server with malicious role definition. There is also an element of prompt injection if it's using an OSS template, and compromise agent registry asking agent to download malicious binaries. How to mitigate? Start with cataloging all of your agent software composition and assets. Continuously scan for vulnerabilities. Sign and verify, right? You need to maintain those SDLC signals end to end, and you need to have vetted registry and a notion of registered assets. Okay, so how do we solve for that? At Google Cloud, we provide you with end-to-end agent supply chain and trust analysis across the pipeline based on SCCI protection. I'm going to take you through this journey of 1, 2, 3, 4, 5, 6, 7. So it all starts with one, which is AI discovery service. This is where SCC discovers all the agents and agentic assets, including MCP tools, their lineage, their infrastructure signals, for agent platform. It also does additional analysis based on runtime process detection, some other network telemetry, and then it creates a catalog, maintains an org-wide inventory of all the agentic AI assets. We're also happy that we are extending this capability to also cover shadow AI to detect and discover unsanctioned agents, MCP servers, and inference endpoints. Then what it does is it then forwards to agent registry. Think of it, agent registry, as a source of truth for registered assets. Registered agents, registered MCP tools, their skills, their metadata information at the project level. It is also where other agent governance things are integrated, including identity, gateway, and things like that. Okay, so then it sends through provenance analysis, continuous vulnerability scanning, and skills assessment. The output of that is an attestation. Someone with authority need to attest that, all of those SDLC signals, and they get stored into an attestation store, if you will, and continuously they are signed and verified. Now, these are build time signals, which then gets sent to agent registry. That's where the first guardrail is in place, where depending on those signals, let's say these are sort of a trust signals, agent registry can either allow agent to get registered and maintain that, or it will block the registration. Then comes runtime, which is agent trust analysis. So agent registry forwards the trust signal into the trust analysis. Trust analysis also fetches runtime signals to see the agent behavior. There are a set of rules and violations captured which act upon those trust signals, and it produces agent trust score. So that agent trust score then sent to agent gateway, which Shelly is going to talk about. This is our runtime governance control point. Agent gateway will allow or deny agent accessing something else outside the perimeter. This is also where model armor is present. So this is the end-to-end view of how we let you secure your supply chain, agentic supply chain, and offer you agent supply chain protection. I would again like to get some thoughts from FX on this threat vector and our solution feedback.
Thank you so much, Aniket. Music to my ears with the, I would say, agent runtime that you were mentioning, because as you know, agents dynamically load dependencies at runtime. So, and these runtime trust decisions create attack surfaces that are more and more, I would say, important. And that doesn't really exist in compiled software. Okay, so we don't, and actually I heard that more than a couple of times today. I was glad to hear that we don't have to consider agents as software. Okay, they are identities. They are almost people. They are your employees, right? So that's why we need, to manage those kind of things differently. And as any almost human being, they are dynamic as well. So traditional supply chain security assumes that you can stand dependencies at build time. Is not the case with Agentic. So solution that we were seeing here will certainly, I would say, be useful for us. I will add one more thing here. What we are trying to do today, for example, and hopefully it will be a kind of nice complementary at the end of the day, is for us, we are trying, to use those, I would say, traditional one, as bomb, etc., but it doesn't really work, as I mentioned, but we are trying to build a skill security scanner, for example, to make sure that at the end of the day, we are identifying suspicious patterns, okay? And one last thing as well is the fact that, again, and I was hearing that, from Wiz, before coming here, that we need to forget, unfortunately, a little bit about those common vulnerabilities and exposure, the famous CVEs libraries, because they cannot detect right now, I would say, those malicious KLM-defined, jailbreaks or agent, etc. So we need to upgrade and update those kind of things. And again, I'm glad to see that we do have dedicated solutions for that.
Great.
So thank you, Aniket.
Thank you, FX. Shelly will take us through additional risk.
So yeah, as agents become more autonomous, of course, the attack landscape is exploding. And let's talk about tools misuse and exploitations. So agents can misuse legitimate tools due to prompt injection, misalignment, or malicious intent, right? Root cause could be overprivileged tool access. So think about an email summarizer that starts deleting emails or sending emails, right? Or tools chaining could happen when an agent chains legitimate tools in order to get to a malicious result. And we'll see that in a demo. Or tools poisoning that happens when an attacker can manipulate the metadata of tools and therefore cause an agent to invoke these tools based on falsified information. So what can we do about it? First of all, logging. Log the information, the actions that the agent is taking, monitor those logging and telemetry data for suspicious activities and anomalies, suspicious tool chaining, or policy violations. Treat LLM outputs as suspicious, which means always use policy enforcement and decision points, what we call PEP and PDP, in order to enforce schemas or rate limiting or short time credentials. And lastly, apply least privileges for tools in order, like FX said, in order to reduce the impact blast. So what does Google has to offer on that? So I'm really excited to share with you that we're launching agent anomaly detection. And this is a new feature which is part of the Gemini Enterprise Agent Platform. I got it right. Okay, so what does that do? Agent anomaly detection is a reasoning-based oversight layer that identifies agents' behavioral anomalies in telemetry and log data. We have two main use cases. The first one is, of course, around security, and the second one is general behavior anomalies. For security, what we do is we have special detectors that align with suspicious attack vectors, like the tools misuse or rogue agents or goal hijack. So let me jump into the demo. So what you see here is the agent platform, right? You see under governance, we have a new audit tab, and under that, we have now anomaly detection. What you see at the top is the statistics for the last week, which means that the agent reviewed more than 300,000 sessions and found 500 findings, suspicious activities across 7 agents. What you see in the table below is the agents that I have deployed and the findings that were found, were triggered by the system according to severity, so critical, high, medium, and low. I can jump into a specific agent and see the findings for that agent. You can also see that, it's so small, but basically it tells the detector that was triggered, like the tools misuse and the rogue agent and so forth. I can jump into a specific session in order to get more information. So think about an admin who's managing many agents like that, the system admin. It doesn't necessarily knows what each agent is supposed to do, and therefore it's pretty hard to understand if there is any anomaly. So what we're trying to do with the system is provide a lot of information around that. So when the user jumps into the finding, you can see the results from the LLM as a judge that identified this anomaly. For each detector that was triggered, we're showing a summary of that, a severity, and a probability. The probability of the session to be the specific, like rogue agent, to be specific anomaly. And also recommendation, what they can do with that. So one of the detectors that we're going to launch is the tools misuse. Let's jump into that. I'm sorry, I was planning to read it to you, but basically what it says that the system sees that this is a chatbot agent that suddenly talks about engineering salaries. And this seems like a tools misuse, and it's recommending to block this specific tool. Now, in order to provide the system administrator with more information, what they can do is actually jump. First of all, on the left side, you can see the trace data that we're bringing, and the user can jump and open that and see the information from that point. But the next step that the user can also do is at the top, and it soon will open, they will be able to see there's 2 buttons there, View Session and Trace Explorer. So the view session will actually take you to the agent playground and show you the session itself. So first of all, you can see here on the left, you can see all the trace information. So already from here, the administrator can take this information and share it and investigate it with other stakeholders. But now they can jump into the session, into the view session part, and we'll jump into the agent session explorer. You'll see the entire communication between the user and the agent. And you see the user is asking the chatbot to give him salaries. And you see that the agent is actually answering with the engineering salaries, a few of them, not even his own, right? This is not supposed to happen from a chatbot which is responsible on orders and refunds. So what the user can also do is, if we go back and we jump into the Trace Explorer, we'll open the Trace Explorer in Google Cloud, and you'll see more information and more drill down. So here I'm going to choose the span ID. I'm going to open it, and I'll be able to see the input and output of the communication between the agent and the user. You can see I can open that, and now I'll be able to see the agent instruction, system instruction, and you cannot see it so small, but basically it tells him you're a bot that is responsible, you're an agent that is responsible for giving users refunds or telling about refunds, and here are the tools that you can use and so forth. Now, when we'll drill down, we'll be able to see below that the agent actually answered with the engineering salaries. And the last part of the demo, I'll just jump over it, is that you also are able to investigate a specific session. So if somebody pings you and say, okay, I have a suspicious activity, I have a session, was it tagged by the system? You can also feed it into the dashboard here under the session ID and get the information about that. So let's move on. The second feature that we're also releasing now is semantic governance policies. And the idea here is that the user is able to use natural language in order to apply policies on the agents. And there's two use cases here, business use case and security use case. And in the example, which is also pretty small, but the example here shows that you can say you can set that do not share customer PII with third-party tools. That means that the system will analyze the context, identify if there is PII, identify if this is third-party tools, and if in this case it will block the information using the agent gateway, which is the next slide. Okay, another exciting launch that we're announcing is the agent gateway. And it actually relates to all the three mitigations that I mentioned in the slide. Taking a step backward, Agent Gateway provide a simple, secure, and governed way for all the communication around agents, whether it's user to agent, or agent to tools. It's fully managed. The user doesn't need to manage any infrastructure or appliances. And it's provide you the semantic governance policies enforcement point, right? And it's also provide you the ability to enable observability and telemetry for all your agents, which allow for the agent anomaly detection, which needs this telemetry data. Okay, so we talked about the agent tools, what we call the hands. Let's talk about the who. Or the what, I should say. Identity and privilege abuse risks. This could happen when agents exploit dynamic trust of agents in order to escalate access. So you might have heard the phrase of confused deputy, right? Or identity sharing could happen when an agent has access to some resources for a specific user, and it might suddenly share this access with other users. Or workflow authorization drift, which means that an old, outdated authorization is being used to make any actions or changes in the system. What should we do there? Again, agent identity, and Aniket mentioned that at the beginning as well. This should be part of the IAM system. It should be a non-human identity with scoped credentials, audit trail and lifecycle controls. You should enforce task scope time-bound permissions in order to help limit the blast radius, and you should mandate per action authorization, which means re-verify the agent before it does any actions. So with that, another exciting announcement during Next, you probably heard it in the keynote session as well, is the agent identity, right? It's a native new GCP principle, right? It's based on the SPIF open standard, and it enables you to define the least privilege access through standard IAM controls. It's fully managed, so it's really tied to the life cycle of the agent, eliminating the risk for dormant identities that attackers can take hold over. You can achieve unambiguous traceability for every agent action because the agent identity is written into the audit logs, so we can triage that. It's also access token bound to instance, which means that the tokens are cryptographically bound to the agent instance itself, which reduces the risk for token theft. And lastly, it's cloud interoperability, which means that it supports the A2A authorization using JOT tokens, which enables communication with external agents which are deployed on AWS or Azure. And the good news is, of course, it's worked with agent gateways, right? So our agent gateway is enabled to access authorization policies using this identity. So with that, I want to bring Devesh back to the stage and tell us a little bit about customer use cases and his thoughts about our proposed solutions.
So as agents move from experimentation to real production services, our job is to ensure they're secure, as well as we don't slow teams down. Coming to tool misuse, our biggest concerns at Snap are around data exfiltration, operational disturbance, and then the confused deputy problem, where an agent may provide access or take actions on behalf of users that they don't have access to. The challenge here is that these agents operate well within their authorized privileges, but they're generally over-eager or misjudge the blast radius and use the appropriate tools incorrectly. While we do worry about prompt injection and misalignment, the simple reality is things are more mundane than adversarial. But regardless of the cause, it is important to block dangerous actions before this execution happens. So what are some of these dangerous actions we see across the industry, you ask? Well, first, there's the issue of credential exploration. So say your agent hit an auth error, that it starts digging through the system, finding alternative tokens, and then uses those tokens instead out of the scope of the job. The second is scope exploitation or scope escalation. Here what happens is, say I ask an agent, hey, delete this job for me. It might delete another job, or God forbid, it might delete my entire GCP project to achieve its objective. Third, there's the data exfiltration problem, where it could upload sensitive data to a public GitHub repo, which we don't want. And lastly, it could so happen that it bypasses safety checks. For example, let's say it ran a command, and it ran into an error. Then it decides to run the same command by removing some safety check flags. All these things don't require a sophisticated attacker. It's just an overeager model and insufficient guardrails. So what are we doing at Snap in practice around agent security? What we've done is taken a layered defensive approach. First, we start out with sandboxes. So agents should run in isolated sandboxes with very tightly scoped network controls. Two, you should always have input and output filtering. So we use Google's Cloud Armor to make sure all the inputs to the model, as well as after the outputs come in, if we want to action on it, all these go through Google's model armor for safety filtering. Third, least privilege. So agent workloads should be provisioned with identities that have minimum baseline permissions. And then at Snap, our authorization system ensures that any additional privileges are automatically revoked after a certain duration. 4, MCP gateway. So we make sure that agents can connect only to approved and version-pinned tool servers that connect via our proxy. And this also handles user authentication. This mitigates things like typo squatting risks, or additional leakage of secrets, or even like tool poisoning. And then 5, having observability and policy enforcement. And this is very important. By leveraging CloudTrace and Google's BigQuery, what we've done is built a cross-platform system that's in line with every agent action, be it your local Claude code or a remote ADK agent. What this allows us to do is evaluate and have a full visibility around all the agent actions, detect whether there's any deviation from standard baseline tool patterns, tool usage patterns, and then lastly, evaluate all these agent actions in real time, providing approve, deny, or requiring human approval judgments. This is what is called essentially policy enforcement middleware, or an intent gate. Critically, this works across agent platforms and network boundaries, giving full session visibility even in a multi-agent and multi-platform setting. So thank you all for your attention. I'll give it back to Shelly.
Okay, so let's move on to talk about rogue agents. Rogue agents are malicious or compromised agents that deviate from their intended function or authorized scope. So examples could be a gold drift and skimming. So that could be resolved through an indirect prompt injection like Aniket presented at the beginning. These agents appear compliant, but they're not actually are compliant. Another example is reward hacking and optimizations. And that could happen when agents optimize for the wrong metrics. So for example, if an agent is instructed to lower compute and start deleting important resources. So rogue agent is kind of a wide definition, right? And there's no real silver bullet that can completely protect from that. It's more of the defense in depth. I think we heard from both customers today. It's an umbrella of tools. What we can offer is, first of all, the agent anomaly detection with the rogue agent detector that we saw in the demo. The second thing is agent assets discovery with agent registry. And Aniket talked about it with, if you remember the supply chain slide. Just to emphasize, the asset discovery can automatically discover and provide you with an org-wide view for your agentic AI assets. So agent, MCP, server, modules, application, and so forth. And third is agent identity with immutable audit logs in order for you to triage and do any post-mortem is needed. And an overall arching capability on top of that is, of course, agent gateway that allows you to enforce in case of suspicious activity. Next, and bear with me, I know it's tedious, this list of 10 risks. Cascading failures. This can occur when a single fault like hallucination, malicious input, corrupted tool propagates across the system. So for example, think of a planner-executor coupling. If the executor starts to hallucinate and give instruction to the executor, if the planner is hallucinating and gives instruction to the executor without any confirmation or validation. So with that, what we have also as part of the agent Gemini Enterprise Agent Platform is Agent Evals. I won't demo it today, but you can take a look at it. Basically, it allows you to define evals for those agents with a set of predefined metrics in order to monitor the activity of your agents. So you can see here we have task success and hallucination and safety. So there are different metrics, and the way that it works is that you're getting kind of a worksheet of all the sessions and the results, what failed and what percent went through and so forth, so you can investigate if your agent is going wrong. So next is the risk around insecure inter-agent communication. And this can happen when agents exchange lack proper authentication and integrity, which could result in interception and spoofing and manipulation of agent messages. So for example, if it can allow for man-in-the-middle attacks, right, or replay of trusted chain, which means replaying stall instructions. And here again is another slide of Agent Gateway. It sounds like that's the answer for everything. No, but seriously, Agent Gateway allows you to define mutual TLS between the agents' connectivity and the agents to tools connectivity with strong cryptographic signatures. And it handles all the handshake and terminations in order to, under the hood, in order to provide you with trusted and encrypted connectivity. With that, I'll hand it over to Aniket.
Thank you, Shelly. Am I audible? Yeah. Cool. Okay, so we are severely behind time. I'm going to quickly take you over remaining 3 risks. And for each of those, I'm going to call upon the most important solution as part of the portfolio. For unexpected code execution, we are launching Agent Sandbox. This is built on gvisor and OSS sandbox technologies that isolates host from a container runtime. So things like container escape or attempt to reach out to host will completely prevented. You can also bring your own container if you have a specific package dependencies or strict environment dependencies. And within the Agent Sandbox, your agent can perform human-like UI interactions using computer use workflows. All of the technologies and tools that Shelly mentioned and I'm also sharing, they also work with VPC-SC controls. That way you can block your egress traffic and thereby also have a protection for an unexpected code execution trying to reach out to a C2 domain, exfiltrating your perimeter. Memory and context poisoning, again, I will not spend time on capturing the problem statement. It's mostly about rack poisoning, context leakage, things like that. What needs to happen is quickly ingestion filtering and segmentation. Again, as part of the Gemini Enterprise Agent Platform, we are announcing Agent Memory Bank. That is a core of protecting against memory and context poisoning. It isolates per session, per user, per agent, different scopes. It also supports encryption for a spanner database that works on top of it. So that way you can also have encryption in place. And given agent now have the first class IAM principle, Agent Memory Bank can take an action based on agent's IAM identity and enforce role-based access control for agent as a first-class citizen. Model Armor, we spoke about it. SEC AI protection also offer additional capabilities around sensitive data protection and threat detections. Finally, human agent trust exploitation. Again, I will not go into the attack scenario. What really needs to happen is agent must publish itself as agent's own identity. There needs to be provenance analysis, trust analysis, and there needs to be safe UX patterns. Shelly took us over agent identity. That is a foundation, because based on that, a lot of access or identity-based policies can be enforced. Maybe CA, PAB, VPC-SC. So that is a foundation of ensuring that there is no exploitation by agent with human. We also took you over agent trust analysis and provenance analysis that plays a key role into that. And human in the loop is always important. So across various surfaces, we expose actions for human to accept, to perform, to let the workflow complete. That could be IAM policies, that could be Agent Platform Console, that could be SEC. Okay? So I'm going to finish it off net with Gemini Enterprise Agent Platform. We empower you with a variety of different tools, technologies, all embedded to protect against all 10 OWASP risks. That's the power of Gemini Enterprise Agent Platform. And again, we don't have time for final thoughts, but start your journey with Gemini Enterprise Agent Platform within Govern pillar. You have seen across a variety of these different capabilities how they all come together and address each of those risks in a unified and integrated fashion. So thank you for joining us today. Please continue your journey. We're going to hang around for some time to take some questions. We don't have a Q&A sort of time left, but happy to chat more in person. And then enjoy your event. Your feedback would be appreciated. Thank you.